Hi guys, welcome to a new video. In this opportunity we are going to solve a problem related with electric fields, and the problem says a small sphere with mass m as charge q hangs, as is shown in the illustration, near to a very large with negative charge insulating plane as is shown. Find the angle theta. Okay, the first step here is to make a free body diagram like this. We have the mass m with charge q, and it is hanging by this cord, and this cord is making an angle theta with the vertical like this. Okay, so we have this, and besides that we have the plane on this side. We have the plane, and the plane is charged with negative charge. It has surface charge density sigma. So what are the forces acting on the mass? Okay, the forces acting on it are the weight, that is the product of the mass multiplying the gravity, the tension of the cord along the direction of the cord, obviously, and the components, the Cartesian components of the tension. What are they? Okay, they are the x component, the x, and the y component, ty. Alright? What is the other force acting on the mass? Okay, we have the electric force pointing to the left like this. The electric force. This electric force is the force produced by the electric field produced by the plane. So this angle here between the y component of the tension and the tension is theta. Why? Because this angle is alternate interior with this blue one. They are the same. By geometry, they are alternate interior angles, so they are the same. And besides that, we have to know what is the electric field produced by the plane. We can do that real quick here. So what we do here is we draw a Gaussian surface like this. The Gaussian surface is crossing through the plane and is a cylinder. And this cylinder has this side with area A and this side with the same area A. Alright? Okay. The electric field on this side produced by this plane is pointing in this direction, is pointing on the right side, is pointing to the left. And the electric field on the left is pointing to the right, like that. Okay, if we remember the Gauss Law says that, I'm sorry, let me erase this real quick. The Gauss Law says that the electric flux is equal to the electric field multiplying the area, and that's equal to the charge enclosed by the Gaussian surface dividing epsilon 0. Alright? So in this case, the area is this area that I am making these lines. Okay, this is the area that we are working with. The charge is the charge enclosed by the surface in this case, but we don't know the charge of the plane. We know its charge density or its surface charge density, so we can work with it. What we do here is that we use the definition of the surface charge density. The surface charge density is the charge dividing the area. Okay, the area where the charge is contained. So if we clear the charge here, we get that the charge is equal to the charge density multiplying the area. Okay, we can take this equation and replace it into this one. Alright, so if we do that, we get the electric flux is equal to the electric field multiplying the area, and is equal to sigma multiplying the area dividing epsilon 0. Alright, and this area cancels with this area, and the result is going to be electric field is equal to sigma dividing epsilon 0. But we have to be careful with this. If we come back to the illustration, we have this area, on this area the electric field is crossing through this area, but the electric field is crossing through this area too, on both sides. So we have electric field on the left side and we have electric field on the right side. So we have two electric fields crossing the areas. Two electric fields, one on the left and one on the right. That means that the total electric field produced by the plane is equal to 2 times the electric field on each side. Okay, and that means that the electric field 2E is equal to sigma dividing epsilon 0, and if we clear the electric field, we have sigma dividing 2 epsilon 0, and that's the electric field produced by the plane. Okay, so we need this equation, and we are gonna call this equation number 1. All right, we come back here to the illustration. We know that the charge is in a static equilibrium. It means that the charge is at rest. Is at rest, is not moving at all. That means that it's in equilibrium. So we use that situation to calculate the angle theta. How do we do that? Okay, because it's in equilibrium, the mass m is in static equilibrium, the total force acting on it is equal to 0. This is the second Newton's law. All right. So, because the total force acting on the mass is equal to 0, its Cartesian components are 0 too. So we have total force along the x-axis is equal to 0, and we call that equation number 2, and we have total force along the y-axis equal to 0 as well, and we call that equation number 3. This is the Newton's law, right? And if we come back here real quick to the number 1 equation, that's the Gauss law. That's the electric fields, and is calculating with the Gauss law. Okay. We use the equation number 2 is total force along the x-axis is equal to 0. Okay, that's number 2, and total force along the y-axis is equal to 0. That's number 3. Okay, we come back here to the illustration and we see what the forces are. The forces along the x-axis are the electric force pointing to the left and the x component of the tension pointing to the right. And we say, okay, we write those equations here and we see what forces act, and we ask what are the forces acting along the x-axis. Okay, we know by the illustration that we have the electric force pointing, we have the component, the x component of the tension pointing to the right minus the electric force pointing to the left, and that's equal to 0. Okay, this is the addition of the forces acting along the x-axis. Okay, we take this electric force and we move it to the right, to the side of the equation, or to the other side of the equation, and we change the sign, and we have that the x component is equal to the electric force. Okay, right. If we go to the illustration, we see that the x component of the tension is opposite to the angle, right? The angle is on the other side. It's opposite. That means that the x component is equal to the tension multiplying the sine of theta. So we have that this equation is going to take this form times sine of theta is equal to electric force. Okay. Before doing that, okay, give me a second. Let me write this part below this. I don't want to go to this way because I need room to write the equations here down. So we said that Tx is equal to T sine of theta by geometry. Okay, by geometry, and by definition we know that the electric force is equal to the electric field multiplying the charge. All right, but if we remember the electric field, what is the electric field? Okay, equation number 1, sigma dividing to epsilon 0, sigma dividing to epsilon 0 multiplying the charge of the mass. Okay, this equation to prime, we replace this part and this part on this part. Okay, and we are gonna get that t sine of theta is equal to sigma q dividing 2 epsilon 0. We are gonna call this equation number 4. Okay, guys, that's equation number 4. I'm sorry, equation number 4. We do the same on the other side. With the other equation, we say, okay, the total force along the y-axis is 0. If we go to the illustration, we see the forces along the x-axis. What forces we have? Okay, we have the tension, the y component of the tension pointing upwards, and we have the weight pointing downwards. So we have here that the component ty minus this equation turns on this way, ty minus mg equal to 0. But we take mg and we move it to the other side, so we have ty is equal to mg. Okay, but the same thing, we go to the illustration and we see that ty is next to the angle, so that's that component is ty is equal to t cosine of theta. Okay, because ty is t cosine of theta, we replace ty on here. We call this equation 3 prime. We replace this on 3 prime, and we get that t cosine. Then we get that t cosine of theta is equal to mg. So we have this, we have that t cosine of theta is equal to mg, and we call this equation number 5. Okay, the next step here is we divide these two equations side by side. Okay, we divide 4 and 5 side by side. We get t sine of theta is equal to sigma q dividing 2 epsilon 0 and dividing t cosine of theta dividing mg. Okay, this tension cancels with this, and sine dividing cosine is equal to tangent, so we have tangent of theta is equal to, we apply this rule here, this mg is like dividing a 1, dividing by 1, and we have here top multiplying the bottom, and this bottom multiplying this top. We get sigma q dividing 2 epsilon 0 mg. And if we take the inverse of tangent, then we have theta is equal to inverse of the tangent, or tangent inverse, is equal to sigma q divided into epsilon 0 mg, and this is the result that we are looking for. So this is the angle theta. Whatever the balls are, for example, theta, sigma, q, epsilon 0, n, and g, we take those balls and replace them into the equation and we get the angle. But algebraically, this is the solution. So hopefully this problem helps you to understand some physics. See you in the next video. Please subscribe to my channel, give me a like, and see you in the next video. Bye.